So section P3 is your prereq, and it's lines in the plane. So this section is going to be about writing equations in slope-intercept and point slope, parallel and perpendicular lines. Your problems that you're responsible from the book are problems number 7, 13, 25, 31, 35, 43, and 65. So to find the slope from two given points, we need to use the slope formula. So the slope formula you could say is, they call it the slope. It could be your m. It could be your change of y over your change of x. And that basically is y2 minus y1 over x2 minus x1. Or it's the same thing if you use y1 minus y2 over x1 minus x2. What you have to realize is that if you use a y coordinate of your first point there, then the x coordinate has to be right in the bottom. Same thing if you use the coordinate of your second coordinate, then that coordinate for your x should be also on the bottom of it. Okay, so now we're going to use our formula to find our slope. I'm going to basically use the first one just because I'm going to have x1, y1, x2, y2. So I'm going to find the change of y over the change of x, aka my m, my slope. And what I like to do is draw the line, put the two minus signs that are part of the formula there, and then substitute in my values. So my values are going to be -5 and the 3 because it goes the y value over the x value. And then my y2 values and x2 value is 13 over my -9. I'm going to simplify. These two plus signs right here become a positive. And then we're going to have -5 and -13. That becomes -18 all over 9, 10, 11, 12. And that reduces to -3/2. And that is your slope for these 2 points. So for this one, we have to write an equation using these 2 points. We're going to use the knowledge from the previous example, and we're going to use the change of y over my change of x, aka my slope. I'm going to find my equation. I'm going to set up my equation. This is my x1, y1, x2, y2, and I'm going to substitute my values. So I'm going to have -3 over the 2, and I'm going to have the 5 over the 3. I'm going to simplify that, and I'm going to have 5, 6, 7, 8. That's -8 over -1, which it gives you that my slope, aka my change in y over x, is going to be +8. I'm going to have this for later on. And the next thing that I'm going to do is I'm going to use my point slope formula, my point slope formula. So I'm going to use my equation, and I'm going to have y minus y1 is equal to mx minus x1. I'm going to use this slope and this coordinate, my x1 and y1, and substitute it into my point slope formula. If you would use the second point, you still got to get the same answer because both points are in the same line. So now I'm just going to substitute my values in, and I'm going to have that y minus my y1, which is -3, is equal to my m, which is 8, times my x minus my x1, which is 2. And now that I substitute out, all I have to do now is distribute my 8. And I'm going to have y plus 3 because these two negatives become positive. 8x minus 16. I need to solve for my y on my left side because I want to write it in slope-intercept form. So I'm going to subtract the 3 from both sides. And now I'm going to have y is equal to 8x minus 19. And this is my equation in slope-intercept form. Okay, this is not the only way to do it. I'm going to do the same process, but this time, instead of using point slope formula, I'm going to go and use slope-intercept formula. So my slope-intercept formula, slope-intercept, is y is equal to mx plus b. you're going to see that I'm going to get the same answer. It's just a different process. I'm going to use the same 8, and I'm going to use the same point. So the point that I'm using, I want to be very clear, is the 2 comma the negative 3, which is the x1, y1, and I'm still going to use the same m from the previous example. Okay, so now when I substitute in there, I'm going to have negative 3 is equal to 8 times 2 plus b. And if you notice, on this time, I'm trying to find my b, and this b stands for your y-intercept. This is where your graph crosses your y-axis. When you simplify this, you're going to get 8 times 2 is 16 plus b. Subtract the 16 from both sides, and you're going to get 19 is equal to b. Now that you have both your y-intercept and your slope, you're going to now write your equation in slope-intercept form, which is what we had before. So we're going to have y is equal to my 8 times my x minus my 19. And if you notice, it's exactly the same answer in 2 different processes. I recommend that you know these equations and forms. If you want to write them down so you can refer back to them later on, that's a good idea. Write a linear function that passes through the given point and has this slope. So that means this is my m, aka my change of y over my change of x. This is my x1 and y1. I'm going to use, again, the point slope. So I'm going to use the point slope formula, which is y minus y1 is equal to m times x minus x1. And I'm going to substitute my values. So I'm going to substitute my values. So I'm going to have y minus, my y1 is 5 is equal to, my m is negative 2. X minus my x1, which is negative 3. This becomes positive. So I'm going to have y minus 5. Distribute the 2. And I'm going to have negative 2x minus 6. Add 5 to both sides. 5's cancel. You get y is equal to negative 2x minus 1. This is your function that passes through the given point and slope. So this is where we stopped in class. I'm actually going to finish this example and the next one, but I will still cover it in class for just in case anyone has any questions. If you notice, they gave us a point 5, 2, and they give us an equation right here. They need us to write a parallel line to the given equation. So the first thing we need to do is write this equation in standard form or in slope-intercept form. So we can identify the slope. So first things first, I'm going to subtract my x to the other side. And I'm going to have negative 5y is equal to negative x plus 4. I'm going to divide both sides by negative 5. And I'm going to have that y is equal to 1/5 x minus the 4/5. Don't get scared. All you really need from this equation is this slope. So my parallel slope is 1/5. Parallel means they have the same slope. So I'm going to write another equation that they have the same slope. So I'm going to use this information, and now I'm going to use this x1 and this y1. I'm going to substitute it into my point slope formula. So I'm going to have y minus my 2 is equal to my new slope, well, the same slope, times x minus the 5. I'm going to have y minus 2. I'm going to distribute the 1/5, and I'm going to have 1/5 times x. And 1/5 times the negative 5 is just negative 1. I'm going to add the 2 to both sides. And now I have y is equal to 1/5 x plus 1. This equation right here is parallel to this one. And they're parallel because they have the same slope. They should have different b's, aka y-intercepts, so they're parallel. On this next problem, it's a lot like the last one we did with one exception. In this case, they gave us the point, negative 1, 3, But now we have to write a perpendicular line to our given equation. Again, we're going to start the same way. We're going to write that equation in slope-intercept form to identify the slope. So we're going to have minus 2x both sides. We're going to have 3y is equal to negative 2x plus 4. We're going to divide both sides by 3 every piece. And we're going to have y is equal to negative 2/3 x plus 4/3. Don't worry about the y-intercept. All we need to identify from this equation is our slope. So this is the slope that I'm going to use. So my perpendicular slope is the negative reciprocal of the negative 2/3. So the negative reciprocal of negative 2/3 is positive 3/2. So this is the slope that I will be using to make a perpendicular line to my given equation, which is this one. Okay, I am going to have to use the point they gave me. So I have x1, y1, and I'm going to have y minus my 3 is equal to my perpendicular slope, x minus a negative 1, which that becomes a positive. So now I'm going to have y is minus 3, and I'm going to distribute the 3/2 into there. So I'm going to have 3/2 x plus 3/2. I'm going to add my 3 to both sides. That goes away, and I'm going to have y is equal to 3/2 x. And we should know that I need a common denominator when you're adding fractions together. So we know that 3/2, 3 becomes 6/2 because I put a 1 under it and I want a common denominator. So I'm going to multiply the top and the bottom by 2, and that's how I got 6/2. And if you go 6 divided by 2, you get that's 3. So you add the numerator, so 6 plus 3, that's 9/2. So this equation right here is perpendicular to that one.